Ora, boa tarde a todos. Já temos aqui malta a entrar também online. Ora, isto vai ser a continuação da aula teórica. Eu queria arranjar uma vítima, ou por outras palavras, um voluntário que quisesse fazer o exercício 7. Mas antes disso, em relação aos outros exercícios, alguém tem alguma dúvida? Sorry, this is in English. We are going to work on the exercises 7 and 8. But before that, anyone has any questions concerning the other exercises? Okay. 6? Desculpa? Não percebi. I 6B, sorry, because I didn't know if you were speaking English or Portuguese and I was 6B, okay. 6B, create boa. This is a nice one. Let's try it. So, were you able to, you put a message on an issue on GitHub, didn't you? Is it solved? No. Okay, so you have another question before this one, no? I know that was in number 3 or something, no? No, number 6. Yeah, because number 6, I'm not sure this bag file is okay, because okay, I will try to do number 6 because yesterday I tried and I couldn't. Let's try. Number 6. So for number 6, we are going to use a bag file from an RGBD camera. And I've shown you one during the theoretical class. And now let's try to do this with this bag file. So if I'm not mistaken, this bag file, yeah, I have it already. PR2 MIT RGBD. So if we go here, I will turn on a raw score, and I am in my bag files directory. So I go to PSR, and I have my PR2 MIT RGBD. So if I do a ROSBag info of PR2 MIT RGBD, these are the messages that I have. So the first problem, Jose, and this is where I was stuck yesterday, is that we don't have point clouds here. We don't have, okay. So the way to create these point clouds is through, sorry? The subscriber will listen to the point clouds, but if you do not have the point clouds in the bag file, you will not publish them when you do a ROSBag play. So we need, in order to create the point clouds that we want to subscribe, so if you do ROSBag play of this PR2 MIT RGBD, sorry, in loop, better. So if this now is running all of the time, and you can do a ROS topic list. And what can you see here? You can see that we do not have point clouds here, because point clouds typically are some slash points. So we only have an image, which is an image from the RGB, and an image, which is an image from the depth camera. Okay, so the way to access the points is to launch what they call the RGBD pipeline or something. RGBD ROS. So this RGBD launch is a package, a ROS package, that is used to set up many nodes. You've seen them today in the theoretical class. There are many nodes. And they each will do something special, something specific. For example, one of them will try to create from the image of depth and the image of RGB the point cloud. So this is the node. This is what we need to launch. Let me see what the problem is that I tried to launch this yesterday and it was not working. Let me try again. So this is OpenNI2 launch. I think this is the one. So OpenNI2, you launch it like this, and it, Maurice document, let's see here. No, come on. No, not yet. Also no. Is it here? No. You installed it. Good. But after installing, I think we need more. So if you take a look at OpenNI.launch, so for example, here I'm going to OpenNI 2. Okay. And if we go to the launch file, here we have the OpenNI2.launch. I'm going to show it to you here. So this one here will launch many, many nodes. This is a big, big launch file. And you have to select this. So typically this is run, this is executed to communicate with the camera. And when you communicate with the camera, you get the RGB image and the depth image, and then you have to launch additional loads to pick up those two images and create a point cloud. Now, what we are going to do is without talking to the camera, because we have no camera, we have the back file. So we have to put the argument load driver to false. Okay? So this argument load driver should be false. So if I do browse launch, OpenNI 2 launch, load driver, yeah. Okay, so OpenNI 2, sorry, launch, load driver, false. So it supposedly launched everything that we needed, except the part that is talking to the camera. And as you can see here, we now have some points which have been advertised. Where I stayed yesterday, the part where I was stuck and couldn't go forward, was that these points are not being published. So let's see if they are being published now. ROS topic, hertz, slash camera, depth, slash points, I think. Yeah. Oh, now they're being published. So perhaps we have the points already. Let's see. RVs. So now we are going to do the... So by the way, I'm going to launch RVs here on the right-hand side, on the left-hand side, because this is starting to become too much information. So RVs here is going to have a point cloud, which is here, point cloud 2. Now we have to select the topic for this point cloud. I'm going to do the camera registered points, which are going to be, okay, points. And for some reason, I'm not receiving them. Unknown frame map. RGBD, where is my camera? Narrow camera, narrow stereo. I think this is it. Okay, but I don't receive anything. I don't know why. This is what happened to me yesterday. Is it a different topic? No.
I used a different topic and I was able to publish the point cloud.
Which was the topic?
I was trying to launch my FD because I saved it with...
We listened to camera depth points a while ago. I can try to check this one. Let's see. There is another way of launching this. I will try it. While you search, I will also search from here. We can launch not by display, but by topic. So I go to the camera, points here. Point cloud. Okay, so there is a problem somewhere. And the problem is failed to transform from OpenNI RGB optical frame to frame OpenNI RGB optical frame. I don't understand this because this is the same frame. This was your error?
Yes.
Well, it's mine as well, and I'm not sure what to do.
But I was trying to add not the point cloud, but the depth cloud.
Yes, I know, but I never use depth calls. I use point clouds. Depth calls, I don't really know what they do. I think they do the together.
Yes, the depth file and the RGB.
Yeah, I don't use those. I've never used them. In any case, I'm wondering why this doesn't work. I mean, I'm receiving the images, but it fails to transform from frame. Ah, I got it. Okay, so this is a deep one, I think, because I think that what is happening is that we need to use a special flag here, which I don't remember. So is it minus minus clock? So we have to create a parameter, which is a parameter called rosparam set, use sim time. This parameter is going to be set to true. So we are going to use simulated time. And now when we are playing back the information in the clock, we need to say that the playing of the back file is going to replicate the time that occurred in the past. So if I run this now, minus h is not supposed to be there. If I run this now, what I think we are going to see, let's see if I'm correct, is the following. So let me search for the OpenAI, yeah, then let me add a point cloud. Point cloud. Now I don't receive them again. Come on. Where are my points? Será que são os outros? Ah, okay. Fail to transform. Again, the same. That's strange. Use sim time, that's the parameter. Será que não é assim que se escreve? Just a moment. Rosparam use sim time. Use underscore sim underscore time. This is what I did, no? Use underscore sim, yeah. Rosparam get use true. So my hypothesis was that when you play a back file, to explain this, I need to draw something. Just a moment. Okay, so this was the hypothesis. When we are playing so suppose that a month ago you recorded a back file. So when you recorded this back file, what you stored a month ago, the timeline. Okay, this is our timeline. So a month ago you recorded the red back file where you had some transformation messages. We are going to learn next week what they mean, but this will contain the information of the transformations in the system. And this was a month ago, and there you saved all these transformations, okay? So these are messages, ROS messages, containing information about the transformations. When you try to run the back file now, if you try to start from here, running the back file, you can do one of two things. You can start running the back file now and say that the messages there have been published a month ago. So the back file can say, here is a message and the stamp is a month ago. Or you can do something different, which is to do what I did when I did the option minus minus clock. this option will tell the playing of the bag file that we are going to run the bag file as if it was today. So it is going to pick up these messages and going to transport them to the present and to publish them as if they have been executed now. So it only uses, so for example, now is the same as the beginning of the bag file a month ago, okay? That's because otherwise you are going to the system, it will be as if the messages are very old. So this is what I thought was happening. I thought that you were not being able to, Arvis was not being able to pick up the transformations because the messages were old. But I'm not sure this is what's happening. Let me search a little bit more to see if I can. By the way, anyone was able to do this exercise or not really? No?
I use the topic for the field scan topic.
Okay, that's a different point cloud. Okay, okay. That's the point cloud from the LiDAR, not from the RGBD camera. Okay, you can use that one. And
but that I get the same with the that cloud that you were getting after the transformation.
but not okay, but not yeah, but not with the laser scan message. Or
No.
just the depth cloud. Depth cloud, I'm not sure it is for a laser scan, for LiDAR 2D. It's for an RGBD camera, I think.
Yes, and I put the depth file and all image RGB.
Yes, but I would try to use a point cloud like I'm using here, or a laser scan better, laser scan. Like this. So
the 6D basically would try to do the depth cloud thing in Python, right?
yes, but so you can have a cloud that comes. Let's read the 6D. You can have a cloud that comes. You can have a point cloud that comes from the tilt laser, or a point cloud that comes from the RGBD camera. You can have both. And in this case, I was trying to use the RGBD camera. If you use the tilt laser, it's a bit more complicated to use. Let me try to search a little bit more because I'm still puzzled with this. I can try to do some debug here, RQT. Let's try to look at our reference frames. So if we take a look at our TF3, oops, this is going to be next week's class, the TF3. This is a big one because this is the PR2. And the question is that, for example, camera link is,
What is the transformation?
Transformation. It stands for transformation. But this is, look, all these transformations are very old because they are 1,000 seconds away, a month ago or some years ago actually. While this here from the camera is very new because our camera is also publishing the reference frames. So we have to tell our driver not to publish the reference frames, I think. Let's see. When I launched the camera, there was also here an option to not publish the reference frames. Where is it? Depth frame ID, blah, blah, blah. Yeah, load driver, no. Publish TF, you see there? 46, this one. Try to launch this again. Publish TF, false. Okay, now this is running again. And if all goes well, we can refresh this guy. And now, no, another. It's still strange.
Is the transfer the number of seconds that there's a number of seconds there.
Yes.
Isn't there from like 1970 to now? So
Yes.
it means that the camera, the oldest one, is on time 0. That means it's 1970. So it's
I think it's recent transform. I don't think it's seconds since 1970. It's seconds that.
Just the last time I played, the last time this was played.
For example, if this was a year ago, this is the number of seconds for a year, I think. So when it says 0, it means 0 seconds old. If you do 2 years, how many seconds are 2 years? I'm not sure. And this is not 2 years, this is like 15 years. See if it makes sense, the number. In any case, I think it is solved because now we don't see that 0 seconds old. Do you see? It's not there anymore. Now, because it's not there anymore, I think RVs is going to like the... again, OpenNI something. Where is OpenNI? Here. Okay. Now, point cloud. 2. Topic. This one? Yeah, this is not being published, so it has to be the other one. Where are my points again? Still a problem. OpenNI RGB. It's the same thing written, no?
I think it has a
Slash before. Could it be that part of the slash? It has a slash here. Frame ID. Open. There is a frame ID something here. Yeah. Yeah, there is no slash here. I could try to put the slash here. Okay, again, new attempt. This is RGBD frame ID. And now slash OpenNI slash RGB optical frame. Just, I don't think it uses a slash, but let's see. Yeah, it's the same problem. I don't know. I have no idea. Let's see. Again, last attempt. And then we move on to the next one because might as well use a better, how to say, a better back file, yeah. Minus clock. That should be okay. And now, new RVs, new point cloud. OpenNI something. Go ahead, Sarah, tell me. Ah, okay, nice. That's it. Okay, yeah, TFs don't use slash, but before they did. Okay, nice. That's okay. Go figure. Let's see. But now I took the slash away. What the hell is wrong with him now? I took the slash away. Because I said no slash from...
I think you need to put the slash there.
I can try to take the slash away from here. But okay. The problem is that what I change here doesn't really do anything because in the images, so the back file is so old, like Sarah said, that it contains the slash and the slash is not possible to use now. So I will show you the images, Roche, topic, echo, slash, camera. This is what, OpenNI, no? Should be. This is a bad back file because this is called camera, but the frame ID is called OpenNI. So camera, deft points. And if we do here with minus minus no R for no array, host topic echo, what? Host topic echo. Menos menos no R. Come on. Então aqui não é a câmera deft points. A câmera deft points should be. Where are these images? I don't think the bag file contains this kind of messages throughout the whole bag, only in some places, I think. I need to launch this guy again. Yeah, now I think he will publish the points. Yeah. So you see here that this guy is in / OpenNI RGB optical frame. And I think this is a problem because there is a slash there. This is not going to work. So if you want, I give you a better bag file for you to work with. Okay, Jose?
Okay. No, but my main question was how do I concatenate in Python to put the point cloud in that list?
Yeah.
It's X, Y, Z, RGB. It's X, Y, Z, something.
It's something like what we did this morning here. You see, remember this?
Yes, yes. It's basically just put
RGB.
after that.
Yes, yes. I'm not sure. Actually, I would have to check in my notes, but what we do, we just search online. For example, I just searched. You searched?
Yeah.
Look, I did this. I searched and I found this guy, which tells you, oh, it tells you how to do an RGB actually. So it's this. So we have to put there the point field. Actually, it's a point field RGBA. Okay. So this is 12 because it's I think 4 bits or 4 bytes. Yeah. No. 8. Now this is 12. Position 12. But I don't really know how to do this. I just copy from the internet whenever I need, and then I adjust. Okay. So try this. Try to use this one if you want. If you send me an email or an issue, better an issue, I will put a better bag file with the deft information. Okay? No problem. So we started off on a bumpy exercise because of Jose. Let's try to go to calmer waters. So exercise number 7. Who can try it? We have, yeah, we would have some 45 minutes or something. Anyone wants to try? Nobody? Really? You did it? So, show us. Okay, did the launch file as well?
Yes, it's marked.
Okay, so let's see the launch file. Yeah, before you launch it, just so we can see what you are launching. So you are launching RVs, the first one, right?
This is the path to
The configuration file?
my configuration file, which is my source of the package.
Okay, so I will teach you something. Just a moment, wait, I'm trying to take away the image because it doesn't allow me to draw. Just a moment. How do I take, okay, here. One thing you could do is this is, for example, you do this for yourself, but this directory is only yours because it's there, José Pedro Pinto, right?
Yeah, I'm not seeing your drawings, but
You cannot see when I draw? Oh.
I don't know if I'm
Yes, I think it doesn't work for anybody. Okay, what I'm saying is that you can replace this home José Pedro blah 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 with so everything up to the package. So there is until aula 10 PSR something, no? This is the package directory. So you can do dollar, is it dollar? Dollar, parentheses, and so find. Now the package name, it's aula-10 PSF. It's the package name. No, packages don't have spaces in their name. Yes, after the find, yes. Okay, now you close the parentheses. This will give you the directory of the package, and then you just concatenate this with /source exercise 7. So you just have to remove the aula-10 / aula-10 PSF. Yeah. Source is already there, so you see. Okay, you see what I mean? You just go directly to the source and then, okay. Exactly. Now, the second part is launching the okay, which you can show us. What does it do? We can try it after some time.
Okay, so basically I just need to know. This is the publisher and publishing tenants. And while this is true, I use a marker to do here.
How did you figure out this all?
Google.
Yes. Okay, that's the way to do it.
Okay, so I Google it, and to avoid them to overlap each other, I use marker sphere, marker cube, and marker test because with the same one the plus last one.
Yeah, for the variable. Yeah. Okay.
Okay, so basically I also use this. This is the namespace.
Yes.
And it's pretty much it. This is I use markers here.
Okay.
And he automatically uses the coordinates and the positions related to the sphere.
Mm-hmm.
This is the scale. This is the output to get transparency, color.
This is the pose, the orientation, the position.
And the position.
Makes sense. So.
And this is the text.
All right. Can you, all three. So I can tell you something, Jose. You said I have to have a different variable, marker text, marker cube, marker sphere. Not necessarily. You could go up a bit more. For example, go down a bit more. On line 41.5, you could just publish marker sphere. So if that was your marker, just called marker, you could publish it here, and then on line 44, use the marker again, because it's like building the marker, publish, and then building the marker again. Okay, could be. You don't have to have different variables, but it's okay like this. Let's see. For a launch file, that's one of the you don't. It's much better that you don't even call it, because that way, you know. Typically, whenever you launch again, if you can, you should restart the ROS ecosystem. But it's difficult to always shut down ROS core. But since you are using a ROS launch, you can just launch everything and shut down everything. And one less terminal. Tab. If you tab it, it will find it. You don't have to search. No, tab. 3, yeah, tab. You just needed to do M tab, and it will automatically fill out, because the other starts with a 3. Very nice. So you have a cube and a sphere. Nice. And the radius. Okay. Can you put the sphere moving around? Let's say, let's make it go to the left and then go to the right and this kind of stuff.
Randomly or
no, constant speed. Let's say 0.1 meters per second. Per second, no, per message published. You already have a loop, which is the while. So it has to be inside. So what are you going to change? If you want the sphere to move, which variable should you change? Exactly. Now, if you make the position increment over time, the sphere will move.
I was going to make an array with okay, I can do that with 0, and after each cycle, EDX will come.
Okay, plus 0.1 because that's what we. Okay, should be to the right.
To the right?
Because it's inside the cycle, no?
Yes.
Okay. Now up there, the initialization has to be outside the cycle. The first one, yeah. Okay. Now,
Now I'm just moving the sphere.
exactly. Let's see what happens. But have you moved to another window or something?
No, it was
Only now I'm starting to see. Only now I'm starting to see. I didn't see, but it no reset will only. Yeah, you have to reset your node. Yeah, it goes away and until infinity, to the infinity and beyond, right? So you have to go. So now say something like this: when you reach 3, you go back. And when you reach -3, you go front, and like this. How can you do it? So if index menor que 3, index, okay. Not really. The else cannot be an else. It has to be elif. My internet connection is not nice. Let me open the door to see if it's ready.
You have to toggle a variable or something, because then you will go to 3, and then go 1 back, and then go back to 3, and then 1 back.
Yeah, that's the goal, I think, to have the sphere going like this.
No, but it's going to 3, and then to 2.9, and then to 3, and then to 2.9.
Yeah, it has to be bigger than -3.
bigger than?
-3.
No, basically, after it goes to 3, it goes 3.1, 3, 2.9, 3, 3.1.
Yes, exactly, that's what
Because
Right. So what I do is I create a variable called increment. So out there, outside the while loop, I call increment equals 0.1. Can you do it? Near the index, yeah. Increment, you said incremental. This is something else.
yes.
Okay, 0.1. Now you go down here. On the bottom, you just say index plus equal increment. So you always add the increment to the index. Not inside the if, outside the if.
Outside?
Yes. Always add it. So you are always going to add the increment. What you are going to do is, if the index is bigger than 3, the increment is starting to becomes negative. If it's bigger than small, you see? So now increment equals minus increment. And the same down there, yeah.
No, increment here is equal to increment.
No, you always, yeah. This is called a flip-flop, I think. No. There, up top, I also negate it.
Here also.
Because when you reach the boundary, you just know that you have to turn back, I think. This way it works even if I start with increment minus 0.1.
Now the condition should be different, I think.
If minus 3, menor que 3.
Because when it reaches the 3, it needs to come back. So the increment needs to be
If
positive.
it's larger than 3.
Yes, exactly. Yes,
If it's smaller than minus 3.
that's it. So actually, what I do is a single condition, which says if index is bigger than 3 or index smaller than -3.
Okay.
Yeah, right. The
To go
condition
like this, I think
like this, I'm not sure how to do it.
okay.
Like, because in these cases, you don't need to touch the increment. You need to touch in the other cases.
So and increment.
No, no. If index bigger than 3
Bigger.
or index, not increment, index. It has to be index here. Smaller than -3. Okay. So when you go over the boundaries, you invert the increment.
Okay.
Try it again.
Makes sense. Yes.
Okay, there you go. Yeah. Can you change the size of the sphere or of the cube, for example, while you are?
Changing the side.
Yeah.
It's the same. Increment reaching infinity or just
No, just you can use the same index there. The same variable index, which is already going up and down to change the scale of the cube. That way the cube is going to be like a heartbeat. It's going to go.
okay.
Be careful because it goes negative. I don't know how.
Yes, Manuel is right. I would do the absolute there of index.
The absolute terms are something like 3 minus plus index or something.
Could be. Okay, let's see.
Yes.
Okay, that's a big heartbeat. Okay, so now what we need to change, well, not change, but that way I teach you how to use visualization marker arrays. So the marker array, you have to check what this message is composed of. So can you Google Roche visualization messages marker array? Okay, so if you go down, marker array, these are interactive markers. This is something else. Yeah, marker array was there. You selected it already, did you? No.
Select what?
The marker array. You did you?
No.
Ah, it was there.
This is the types. This is just marker. It's the picture. Markers. Marker.
Yeah, that's it. So if you take a look at the visualization marker array, the only thing that it contains is an array of markers, as was expected. But this shows you how you can search online for the information. So let's create a visualization marker array. Go to your code, and it's already imported. Okay, you can do it actually on line 3. You can do comma marker array instead of creating a new line. No. You want the marker and the marker array. So you have to do marker, comma, marker array. That's it. Okay, now, in your while loop, you have to start by initializing a new marker array. So let's say marker array equals marker array capital. That's the type. Like you are doing on line 23. Okay, now after you create your sphere marker, you just have to append it to the list of markers. So there you do marker array dot markers, that's the field name, dot append because it's a list, and you put there your marker. Marker sphere in this case. Okay, now you have to do the same for the others. You forgot to change marker sphere. Okay. Okay, now we have a marker array. We need to publish it. So let's take a look at your publisher configuration. So in the beginning, you can do there publisher.publish marker array. But something is going to be wrong after you do that. And what is array? Yeah. So comment the other three. Okay. Well, now you have the control C, you cannot complain.
Yes.
Now you have to change this, exactly. Okay, let's see it again. So the marker array is used so that you publish a single message containing many markers. That way you don't have to send. It will. It will. Okay, now your RVs, now you have to configure it to use marker arrays. Okay. Okay, there they are. Okay, no problem. Any questions concerning the marker arrays? No? So our RVs is going to be very valuable for us because we are going to use it extensively for many, many things. If you didn't do this exercise, you should. So now we go to exercise 8. Who volunteers? Let me see the time first. Okay, we have time. So who can volunteer? Exercise 8. Anyone tried it at least or not? No? Manuel, you are talking about the time before, in 20 minutes ago, you put something here in the chat. So were those numbers plausible?
I think they were, I don't remember actually the numbers, but I think it was the time from 1970 to the time it was recorded.
1970 to the time it was recorded.
But
it doesn't make sense that the most recent one, the nows are 0. That way the nows should be very big, no?
Because when it was 15 years ago, it's like 400 million.
That's what you have here. That's what you have here. Okay.
And from 1970
it's 1.6, blah, blah, blah.
It's 1 billion. And I think the ones were 1.1 billion.
I think they were, yeah. Okay.
They were something like that.
So who wants to do number 8? You want me to do it? Or what? Can I choose a victim then? Luis, you want to try?
No, not really.
But do you have it ready or? No? Okay. And you, Miguel, do you want to try or not? Okay. You will say Lucas. And you, Lucas?
I actually, I haven't tried.
You haven't tried?
I still in parts of the night.
Okay. You are also quiet. Nobody wants?
I haven't done it, but I can do it.
Okay, Manel, you go. The only brave guy here, him and Jose today. The other day. Yes, we are seeing the 473 million billion or something.
So what we need to do, I need to
Unmute myself, I think. Yeah. On exercise 6, implement a ROS node that reads laser scans and clusters the various objects. Oh, it's the ones that the professor showed us this morning, right?
Yes. So whenever you start an exercise, I would say, where's the closest thing that you have? What's from everything that you have, all the code, what's the one closest to the goal?
It's exercise 1, I think, that you read laser.
Yes, that's it. So exercise 1 is your starting point because that's the closest to the goal.
I'll create a folder because I haven't. Just create a direct.
You haven't done it?
I have done exercise 1, but I haven't created a folder. It's only in a package, so I can just copy and paste this inside the folder. Okay.
Manuel, watch out. You are copying a ROS package?
Yes, I'll,
Now you're going to rename? You cannot have two ROS packages
with the same name, yes.
It's going to complain.
The thing I was doing, I want to delete this one, the first one.
Ah, okay.
It's just to move it here, and then I'll copy and paste, and then I'll change the name to exercise 8, and then I'll refactor it,
Okay.
everything.
Okay. It's a lot of steps. I hope you know what you're doing. I think you do.
Okay.
That's why I will trust you.
What I'm doing is I did Control Shift R, and then I will replace on the folder that I'm in, which is the new package. I'll replace everything that mentions PSR aula 10, in this case, with PSR aula 10 exercise 8.
And did you see? No, what, in the directory? Okay.
It's
makes
in the
sense,
directory,
makes sense.
exactly. And I'll replace. And some occurrences, I don't know what this is, but one good way of, let me stop this.
A ROS CD, for example. Is that what you do?
What I was doing, I was compiling, because if something's wrong, the compiling goes wrong. That's what I usually
Compiling
do.
takes a long time. ROS CD is faster.
True.
ROS pack profile. You have to update the package.
Okay, true. PSR.
What's this the name?
It's
okay, there it is. Okay, I think it worked. Good.
Okay.
Now, the code from exercise 1, is it there already?
Yes, it's in here. It's in here.
Okay. So this code will subscribe
To the one I give it to him. And then it was giving some errors to me, but
Let's run it and we see
reads
what were
laser
the
data.
errors.
I think there were some that I was trying to do right now. There were some parts that were not defined. Like I didn't define the height and the width. I don't know if those are crucial.
Yeah, it could be. Well, run it and let's see.
Because I think it's row step. I think the row step was giving me some hard times. I can try and run it. I'll do a raw score. Can do a ROS run PSR. Exercise 8 and listener to the topic. I think it's better to run the ROS back. It's on my download folder, which is not the correct spot. It's not the better spot to be in. But I'll do ROS back play. It's LiDAR example /L.
Okay, makes sense.
Okay, it's running.
Okay.
I can do the ROS topic list, so I can not list, so I can see where it's it. It's this one. Can copy and paste it. And it's listening. But the problem is when I listen to the point cloud, I can do a ROS topic list again. Now there is a point cloud, which I can listen here with ROS topic echo. And there's an error in here. I can stop it so you can see.
Okay.
It says something like, now it says field data must be an integer.
Inside
Is it not an integer?
Okay, we can take a look at that.
Okay, sure.
Let me see. So you prepare a header, and then you put X, Y, Z. Let me compare with mine just a moment.
Sure.
LiDAR subscriber. Okay. Then you are going to do points z equals 0. You are going to travel all the ranges, compute the theta, compute the x and y. Why are you putting these two integers?
Because it says in here that it's an array of integers.
No, that's a binary array. It's like a mask for the data. It's not real coordinates. It's, yeah,
Okay.
you don't have to put there integer. Points append, rows by publisher, point cloud. Can I see the publisher configuration?
The publisher configuration. The publisher is called right here. Should it be called
Yeah, you shouldn't create a publisher
inside the subscriber? Okay.
Yeah, but you can also not create it inside the main. Otherwise, the pub variable will not be seen by the
Yeah.
callback function. So one, either you put a global variable pub, so you create the publisher outside of the functions on
Yeah.
top, or you use the partial. Let's use the simple version now. So put the pub up top before the functions, so that it is a global variable.
Okay, and I can.
Point cloud to. Okay, makes sense. You don't have to, when you put it outside, you don't have to save.
Okay.
Now, okay, so just a moment. This point p cloud line 26. Let me just see. So I do point cloud dot. No, I do it like this. I'm going to put it on the chat. Okay.
Okay. Sure.
Perhaps this is what is not working. By the way, can I draw on your screen? I can, no?
Yes.
I don't know why I cannot draw on some of the other screens.
Okay, so instead of this.
So your p cloud is going, you can say p cloud equals that.
Yeah, p.
And then you just publish it. And you should comment line 29 to 31.
29. Okay.
Let's see if it goes like this.
Okay. Okay.
Okay, now it's working.
Yes.
Actually, I just wanted to show you how it works because now we are not going to need this because we are not going to publish point cloud.
Point clouds, exactly.
Anyway, if
yeah.
you want to copy this code to the exercise one, you can just copy the.
Sure, I'll do it later. Yeah.
Okay. Yeah, but now I'm going to erase this.
Oh, okay. So yeah, it's better to do it now. Okay. Override. Okay.
Okay. Now, one thing that I would say it's unrelated, but can you go down, please?
Sure.
Last week's class was about remapping and name remapping.
Yes.
And
The R parse is not needed.
not needed. Yeah, you can just take it away, and let's do exactly what you are doing without the R parse. So you need node listener, then this is going to be the topic. Just say laser scan topic, something like this.
Yeah.
Or laser scan, yeah. Okay, so now you can, in the terminal where you launch this script, you are launching it like a la argparse, but now you can launch it a la rows, which is the name that you want to remap.
Which was left.
Laser underscore scan underscore topic, you said?
Yes, laser underscore scan underscore
Two
topic.
points equal.
And do I need the slash? No.
I think so, yeah.
Slash. Let me do a cross topic list.
It's left laser scan, I think.
Yeah, but it's easier to copy
Yeah.
and paste. Is it not saved? Or am I running the? I'm running the.
Did you change the
Sorry,
right
I
line?
changed it. Yeah, I was on the wrong one. Sorry.
Okay.
Yeah, but
Again.
I can do it on this one. Let me just change it from exercise 8 to exercise this. Okay.
Okay, so now it's working again, no?
Yeah.
So you still don't need the argparse. Unless for some very specific custom thing that ROS doesn't provide, which is rare. Now finally we have the setup for going into exercise 8, right?
Yes.
Because we are receiving a bunch of range messages. So how do you propose, what's your idea of an algorithm to do the clustering? Can you just draw something, some idea? What do you
Yes,
suggest?
sure. I think it's based on a radius because this is a 2D LiDAR, right? It's a laser scan. So imagine viewing from the top, you have something like this, and you have something here like this, and something like this.
Yeah.
And these are a lot of points who are really together. I can say that one point, it can draw a circle around it with a certain radius. And if there's a point inside that radius, those 2 points are connected. And it's one.
All right, so let's see. For each point, x, you want to compute the distance to all points, all other points?
No, I want to draw. I want to see if there are some points inside the.
Yeah, but this is just to draw is just a way to it's just
Yeah,
a
sure.
schematic. You need to compute the
I
distance.
need to compute it for everyone, yes.
The way you are saying,
Yeah.
you do, but this is going to be difficult because this is going to be a very high complexity for the algorithm, because if for each point you're going to go to all the
Yeah.
others, it's going to be
True.
difficult. Is there a way?
We can use
we
the
can do a
because
better way, no?
we have angles and we have increments, and we can compare with the increment before it and the increment next to it.
Exactly. I think you just have to, because these are ordered by angles, you can
Yeah.
just compare this one with two, and then two with three, and so on and so forth. And
Yeah.
that way you don't have to compare one with all the rest. This
Yeah.
is a much smaller complexity.
Yeah.
Okay, and this comparison will be based on the distance.
Based on the ranges, exactly.
Okay, you can just compute the Euclidean distance between them, for example. That's
Okay,
the
sure.
schematic
What
of
I
the
was,
radius, no?
I think the way I'm thinking is simpler. I don't know, because they all, besides the angle, they also have a range value, and imagine the range here is 20, and we can define a certain threshold, because this one would be like 19.8 or something.
Okay, you can use the raw instead of the
The-
Euclidean distance in Cartesian coordinates.
Exactly.
It has some downsides. We will take a look at them. Well, not so much. Let's use the raw, no? So you're going to use the raw for evaluate. So basically, you're going to compare the raw of measurement index with the raw of measurement index plus one.
Plus one, exactly.
Okay, so we compare the neighbors. Makes sense for
Okay.
me.
Okay, sure. Let's do it here.
Are you sure you're in the right file? I always get a bit nervous when I see so many files open.
Yeah,
I never know if you are touching the right one.
Now I am. Okay, I need to erase this because it was not in here.
Okay.
And now I can define here
We call
a
it
left laser scan topic. Exactly.
Actually, another convention that is typically used, you don't do a name that is going to have to be remapped. You do a name which is a good default. That's why typically there we put laser scan, which is a default laser scan
Okay.
topic name.
Okay. Sure, now I can erase this. And I can comment this because I believe this way we're going to use this next. So,
Yeah. And
I
the
can
part
comment
about
the headers and everything, yeah. And Z.
Okay.
Okay. So now I can use the for cycle. And I can say, I can define the angle again. No, I don't think it's needed. Is it needed? I think you can just say that, I can say that range, is range a list?
Ranges.
Ranges.
Ranges is a list. Ranges.
Okay, I can say that I can define a threshold here. Let's imagine 0.2. And I can say that if I can messages, I can say range 1 is message dot ranges of IDX, and range 2 is message dot ranges IDX plus 1.
Okay, just some comments. IDX,
Yes.
I think, should be in brackets instead of parentheses.
This?
Because these are, yeah, because these are lists. I think they should be.
Oh, okay. Thank you.
Second thing, so you, in fact, you are computing a range now and the range previous, or in fact, the range posterior. That's what you're
Yeah.
computing. So the range now is called range. You don't need to put it again.
Okay.
The range posterior makes sense, but there is a problem because when you are on the last element of the list,
It will not work.
that yeah, it will abort. So just say something if. Yeah, just say if index is the size of the list, do something.
Length of message range. I can.
I think you can also put message dot grades -1. So it goes
-1. Yeah, you could
in the form.
here you could have enumerated MSG dot ranges,
Oh,
and now you select everything except the last one.
yes. Okay.
I think it's even better.
Okay, better.
Suggestion.
Nice suggestion. Thank you.
I think I have another one.
Okay.
The idea is to use a zip. A zip puts together
Two different
two different
lists.
Yeah. So for example, suppose that you have this list. Let me do it here, okay, Manuel? It's
Sure.
just a parenthesis and then we go back.
I'll stop my screen share.
I was going to interrupt it. So let's see, Python 3. So let's say you have this list, odd numbers, 1, 3, 5, 7, 9. B is even numbers, 2, well, actually you start at 0, 2, 4, 6, 8, okay? Now, if you want to iterate these two, you don't have to iterate them separate. You could just iterate them like this, zip. So this is like putting together the two lists, provided they have the same size. And the output of this is an object that if you convert to a list, is actually tuples. So 1 with 0, 3 with 2, blah, blah, blah. So if you have your message of ranges, let me draw here my message of ranges. Let's create from this message the ranges. The ranges, exactly. So this one will go, so the ranges is this. The first ranges, the red ranges is like this. Now the the green ranges, I'm not sure how you do it. It's 1, 2 points, I think. It's going to be like this, okay? So they will have the same size, but this one will have the first, on the first position, it will have the first value, and while the green will have on the first position the second value, and so on and so forth. So now you can iterate with a zip between these two lists.
What will happen if they don't have the same size?
No, I think not. We can try. So let's see here. Let's redefine B. Oh, it works. I'm not sure what happened here. So 1 with 0, 3 with 2, 5 with 4, 7 with 6, 9 with 8. Well, what happened? I took off the 10? I took off the 10. Okay, yeah. It cropped out the exceeding one, yeah. Okay, Manel, go back to you. So how can you create these ranges? Ranges, okay. Yes, it was. I think that was it, yeah. no. So you have the range I and the range I1, I2 or something like this. Range 1 and range 2, yeah, perhaps. Yeah. So that means if this is smaller, it's the same object, right? And do you want to detect if it's the same object or do you want to detect if it is a new object? It depends on what you want to do next. I did the opposite. That's why I'm asking.
We want to create an array of topics. Create an array of topics. Okay. So we need, yeah, we can do it different. If it's the same, we can append it to the list, right?
Yes, we can append it to the same list. Yeah, somehow. But before that, before I understand what you are talking about, so what do you want to do? So we know that we are going to have several points. Oops, sorry. Here. We know that we are going to have several points like this. And what exactly do we want to do? We want to have what? For example, what I did was a marker array. So that's an array of markers. Each marker would contain a group. A list which is an object with a list of spheres, for example. An object of markers. So yellow is a marker, red would be another marker. So if you want to do this, you have to create a marker for each group.
And I can, after I create it, so when it's something like this, I can publish a marker, right?
Not if you are going to send a marker array in the end. If you are going to send separate markers, yes. But if you are going to send this marker array, you don't publish it, you just push it down inside the array of the marker array. So, okay, so continue as you think is best.
Okay, let me just see the marker messages.
Yes, I can try to help you there because there is a place where I copy from, although I never find it. Let's see. Cross visualization. Yeah, that's in C++. We need to adapt. That's why I want. Yeah. Here, Manuel, take a look at this one. It's easier, I think. Otherwise, you are going to change a lot of stuff from CPP to Python. Okay, so you create a marker. You feel. So you are not going to. So there are several types of markers. If you go to the yes, go to the documentation. You had it before. That's here. It's here. You go up. I'm not sure. This is slow. For me, it's blocked. Yeah. Perhaps you pause the screen sharing. I'm not sure. Yeah, better. Okay, now. Yeah, it was no, it was. Ah, okay. Catching up. Yeah, so now you need to do a list. So you cannot just send a sphere. It has to be either a cube list or a sphere list, so, or a point. But try, for example, a cube list. So a list of cubes, because you are going to have several points on each group. Okay, cube list. Now the action is always add. You don't need to put it there. This is by default. If you want, you can take it away, but you can also leave it, no problem. So orientations, so for each marker is, regardless of it's a cube, a single one, or a list of them, you always have this pose of the marker or of the object or objects, and this pose will transform all the objects. So for example, if you have a sphere or a list of spheres here, if you put a position x equals -5, all the spheres will move. So here you can just put 0, 0, 0 for all of them, let's say. With regards to the orientation, there is it is represented as a quaternion. Quaternion is a compact way of representing rotations instead of a 3 by 3 rotation matrix. And the quaternion needs to, when it is an identity rotation, so a 0 rotation, it needs to have the W component to 1. Otherwise, it's not normalized or something. So that's why we are putting there on line 29 the orientation.w to 1. Okay, so now we have a scale, we have an alpha, we just need some color. We just put some. A is alpha, the transparency. So you have to put color dot. Exactly. So my suggestion, this is already, a lot is made. What I suggest is that, now, let's say you don't know. So go back to the tutorial where you were, and you see there that color is a standard message color RGBA. Search online. Yes, click there, better still. Okay, so it's a float RGBA. Call me maniac, I would put RGBA instead of ARGB, just to be. Yeah. So this will be white with full opacity, with no transparency. Better put some, yeah. Okay. So now you are going to put a cube list. If you go back to the documentation, there is another field below, which is the points. So you see there, points. So each point will give you the coordinate of one cube. The size of the list of points is the number of cubes. So now you need to create a list of points.
Now I need to do these calculations.
So what I did in the last class was, whenever I went to that if, I created a new marker. And what I'm doing is always adding to the last marker in the marker array. So if you go to your code, for example, go to your code, this is inside the if, right? So this is what happens when diff bigger than threshold, not smaller than, bigger. So this is what happens when you have to create a new group. So when you have to create a new group, you create a new marker and you put it on the marker array. So you have to create a marker array variable, something like, yes. Okay, and after you create a new marker, put it inside the, put this marker inside the list of markers in the marker array. So marker array dot markers dot append. Okay, so this is just, oh, do I need a new group? Create it. And now, the rest of the code doesn't really need to know if there is a new group or not. Why? Because it's always going to add the point that is reading on the last group of the list.
We only have one marker for each group.
Yes. Yes, because each marker has a list of points, of cubes in this case. Yes.
But I will get to the first one because
The first one, we need to make sure that this if will be activated on the first point. So, or better still, create a marker that you add on line 17 and a half. Just put there one. But you're going to have to copy all the lines from 23 to 34. Put them in a function. You can create a function called create marker.
first put the if bigger than dash or range one. Range one. And then
Range is a number, is the distance. We don't have the index again. Yeah. But this is going to be nice to have the create marker function. Otherwise, the code is going to be very big. Yes, like that. You read the, you can define other stuff, but for now, don't worry about it. Just return the marker. Let's do the skeleton and then we complicate it after everything. So just change the frame ID. Neck is not world or map, something like standard. Without the slash. This is what Sarah was saying. No, you don't do the same there because there you're going to call the function. That's it. And do the same on line 37. And you have to do the push. So you have to do a 43 on 37 and a half. Okay. Something like this. Okay, so create a marker, and then if needed, you always change the marker. Now, is it okay, Manel? It will if the range 1 is similar enough to the range 2 so that you don't enter the if.
maybe it needs to be inside 4 and before it.
Oh, I think not. Why?
Because it will append, it's appending here. Can I change it while appending?
Yes, you are going to change it. Yeah, I will show you how. So on line 45 or 46, just a moment, Jose. Then you ask if you don't understand what I'm suggesting. So now what you go down a bit, Manel. Yeah, now you need to append the coordinates. So these are going to be x, y, z coordinates. So you do have to convert these, have to do the lines 48, 49, 50 to get the x, y, z. No, outside. Yeah. So you need a theta. So you're going to compute. Now we need the index. Now we cannot escape the index. You have to do the enumerate. I think it has to be index, comma, parentheses. I think so, because it's an enumerate and then a zip. Okay. Okay, so now this is the x, y, the z is always 0. Now you need to do, now you have to append to the list of points in the last marker. So how do you get the last marker from the marker array? You just put last marker equal. It is so this is just a so last marker equals marker array markers brackets -1. Yeah, so that's the last one. So now last marker dot points. This is the list of points in the last marker. Yes, you will append because this is also a list. No. Now I have to check the type. It's a geometry messages dot point. Check it. You have to. It has to be a point, a geometry message point. No. From geometry messages dot message import point. Yeah. It's dot message. If you compare with line 8. Okay. So now you need to create a point and then append it to the list. There you can say x equals x. Exactly, better still. Yes. Yes, I think it makes sense. And now all that is missing is the publication of the last marker. Oh, sorry, of the marker array.
So after the for cycle, I can do the same thing that I did with point for.
Is it there? I think so. I think it will work. There is only one thing that we didn't do yet, which is we are in fact putting the stuff in different markers, but all of them have the same color. So one thing you could do is to randomize the colors to make sure it's different from group to group. So whenever you create a marker, you can randomize the color. There is a function to randomize a number between 0 and 1. I think it's random.random. But search. It's nice that you learn how to search. Okay. You didn't have to restart the back file, the ROSBAC play. You could have just let it run.
My launch file is not prepared. Do you want to do this, or can I just?
The launch file?
Yes.
If you want, I think it's going to work right now, yeah. Because even if it doesn't work, you don't have to shut down ROSBAC play, nor RVs. You just relaunch your node. That's the only thing that needs to be relaunched. Now it's not called laser scan topic, it's only called laser scan. It said something at the beginning, but I think I know what it is. It was just a warning stating that you need to be explicit about the queue size. So if you go to your line, yes, queue size equals 1 or something. I typically do 1 if I don't know what else to do. RVs, which should be in a different workspace. No. Yes, it was supposed to be world. The problem is that if this is world, then we are going to have the markers that we published in the world frame and the points from the message from the original raw laser scan message in the left laser reference frame, and you have no connection between them. Might as well in your code, go to your code, please. Yes, just put there, you can hard code it to left laser, it was just that, I think. So this is the original one, right? It will not expand because there are no transformations being published. You need to write it, left laser there in the fixed frame. Okay. Okay, these are the original data points. Now let's see how you can cluster them, no? Yes. Check. I think you didn't relaunch after you changed the frame ID, did you? It's there already, but so you only have 2 points, period. All the points are on. Okay. Now, what's happening? We didn't went through this when Jose was showing this because he already had fixed this problem. When you send a marker array, you are sending multiple markers. Supposedly, they are supposed to be different because if they are all the same, because if they are all the same, how come you send them in a single message? So you must make sure that these markers are different. And how does RViz know if the markers are different? It uses 2 variables to check, which are the namespace and the ID. In your case, all the markers have the same namespace and the same ID. So just change the ID from, what are you going to do, a random there? Okay. Don't call it something else. If it's called ID, call it ID in there. Yeah. Yes. Go ahead, Jose. No, it's ID in the function. It has to be either one of them different. So the namespace can be the same. Although it would be nice to have group 1, group 2, blah, 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 but it's okay like this. Now we have a lot of rainbow. Okay, so what's happening here, I'm not sure if you understand, is that every laser scan message will contain different data points because things are moving in the scene. And because things are moving, you are going to put different colors for different groups, but the colors of the groups are not going to be the same from message to message. So can you go to your terminal where you are playing the back file? So select the, space. No, yeah, space, yeah. Now go to the RVs. Okay, so can you zoom in? Let's see if it is making sense. For example, no, there it's not so nice. I think it's your 0.2, it's too small. There too, but there it's a lot of colors. I think it's too small. Yeah, let's see. Actually, you can also use yes for step, just a single message. Still, we have these places where it changes a lot. The reason for this is, I know it because I looked at it in the other class. Can you do a terminal there? A white canvas for me to draw on. Gedit, come on, something like that. Gedit, okay. Everything is black? Come on. Okay, I draw in red, don't worry. So this is the laser scan. And here you have a point, the data point. And then you should have one here, and then you have there again. So this is one angle, another angle, another angle. The problem is these are beams that are sent through the laser, and sometimes these beams may not come back to the sensor. So the way to evaluate the distance is you have the sensor, which sends a beam. The beam will hit an object, and when it hits the object, it's reflected in the micro surfaces of the object, because objects are, even the flattest ones have this kind of micro surfaces. Well, not visible, but micro. And this reflects the light beams, and they come back. And the time they take to go and come back will tell you the distance of the object. Now, what happens when this kind of micro surfaces do not exist is that the beams are not reflected. They are only, não é refletido, é refratado. Yeah, I don't know, or refracted, I don't know how to say. Do you know what kind of objects do not have these micro deficiencies? Mirrors. Mirrors are very flat. That's why lasers do not work on mirrors. So if this is hitting a mirror or something similar like a non-reflectable object or something like that, on this direction, on this angle, you will not have a measurement here. Now, if you don't have a measurement here, what typically it says, it's called this not a number. But because you have to put this in a back file, this not a number was converted to a 0, which is an absurd measurement because the laser can never measure 0. But still it's a number. So this R for you was, so let's say this R for you was 2.5 meters. And then this R in the middle is going to be, this one here is going to be R equals 0. So 2.5 to 0 is smaller, is bigger than 0.5 than your threshold. So somehow you need to detect that you are having, how to call them, inconsistent, sorry? These are not outliers, these are invalid measurements. This is what we call them. Outliers is I put it typically smaller than 0.1, for example. Let's say that the LiDAR cannot measure anything below 0.1. So if you go to your code, what I did this morning, and it worked quite fine, is we are here iterating over all the measurements. So we can just take a look if range is invalid. We just continue to the next one. So we don't create a new cluster. So just check if your range 1 is bigger than, or actually you are going to check when it's invalid. So it should be smaller than 0.1 to be invalid, or range 2 smaller than 0.1. And then you continue, yes. So if any of these measurements is invalid, we continue and we don't do any of the rest, including creating a new cluster. Try again. Still not nice. What's that? Yes, S is to do step by step, but I'm not sure you will. Well, try it. Try to visualize it. But I'm. Yes, the arrow here, Manel. Oh, there is a yellow one. Try to reset RVs. There is a button here to reset. Okay, now again. Okay. So what we were seeing was data from previous executions of your code. Okay, RVs was having everything there. Now it's okay. Now it's running fine. Of course, then if you now change the threshold, it will probably, for example, connect the pink with a, try to do it. Put a bigger threshold to see if this one connects. Not sure it connected. Not yet, no, not really. But you were very conservative putting the threshold. Yes. Be ambitious. Everything, yeah, just a single color for everything, probably. Did you reset? Yeah. That's strange. Still, 2.5 is a lot. I'm not sure. But I think, where is the LiDAR? Can you add an axis so we can see where the LiDAR is? It's there. Yeah, I think so. I think it's like this. Look, you measure this, and then you measure this, and then you measure that. So it's two. This could be 2.5, no? Well, if you want, just put 50, and for sure it will all be the same color. Just to see if the everything is working. So 50 meters. Although this is a room, it's 50 meters. But well, 50 meters is a lot. No, not sure. I don't think so. No, okay, now all the same color, makes sense, okay? So what I tell you is, Manel, can you go back to put 0.5 or 0.8 and just let it run? Sorry. Yes, you are going from desktop to desktop. Just let it run, yeah. Now, the problem here is this. As we saw before, the same cluster will contain different colors from iteration to iteration, from message to message, because you cannot ensure that they have the same index or that the random will be the same. So if you want some homework, you can try to do what is called association. Well, actually, for an Altino, this is important, perhaps for you too, I'm not sure. But this association is what people do when they try to do tracking. So what are you going to try to do? You are going to have a list of groups in the previous iteration, I, and the list of groups on I plus 1. And you have somehow to go through all the groups in I and try to compare them with the groups in the previous one, something like this. And, sorry? Define a threshold, but you need to compute. So the threshold is only defined after you compute how are you going to do this difference between groups. One suggestion is to, for example, compute the difference between the centroid. You can do the centroid of the group and then compute the difference between centroids. And the threshold will be the threshold on the distance between the centroid. But it's very difficult. It's very difficult. Look, 1, 2, 3, 4. Yeah. And now this is the other one. 1, 2, 3, 4, 5, 6, 7. This is the same group. Still many different points. How do you compute this? It's not easy. I mean, if you use the centroid, like I'm doing, you are going to compute the difference between the centroid square blue and the centroid square yellow. This is what you compute. What you are suggesting is harder to implement. You have to. Mm-hmm.
You see, for example, the first yellow point.
Yes.
You run all the clusters, and you see if this point moves a lot or not. You define a threshold. Let's say if the mean of the moving of that point is like 0.1 or 0.2, it probably belongs to the previous cluster. If not.
Ah, okay, okay. I see what you mean. So you are thinking of a different thing, which is also interesting, perhaps even more. We are doing association between groups. What you are thinking is associating the groups from before with the data from now. So you have a group and you try to see if this point belongs to the group. It could also be, yeah. So you have homework to try. If you want, but something I want to tell everybody, because it's important, for next week, let me share. Thanks, Manel. For next week, don't forget to prepare this part. Where is it? I'm also lost, PSR. PSR solutions, where is it? Solutions. I'm going to make it available today or tomorrow, the latest. And we are going to discuss geometric transformations in ROS, okay? So this part is how ROS is able to use many different coordinate systems. And the theoretical background is a bit more hardcore than usual. So I'm saying you should see this video that I did. And I want you to see it because otherwise I would spend 40 minutes explaining. This is a 36-minute video, okay? If you don't see this video, you will not understand what ROS is doing because you don't have the theoretical background. So if you do nothing else for next week, see the video, okay? This is the most important thing. Okay, that's it.
I have a question on Manel's code.
Can you share, Manel?
Basically, on the marker, we are coding the position 0, 0, 0. And then we are putting the coordinates where we are changing it. It's the x, y, z. It's dynamic on that position, or we are changing something else.
You're right. Your confusion, I think, comes from the fact that we are putting x, y, z coordinates on two places, two different places. The first is this marker.pose.position. In fact, there we have a position. And the second is in the marker.points dot x dot y dot z, right? What happens is that we have this coordinate system x, y. This is the coordinate system of the frame ID. So whatever you put on the frame ID, in this case we put left laser, no? And then we want to have a coordinate system, which I'm going to draw a bit smaller, which is going to be, this is not a bit smaller, this is the same. For example, like this, and this is going to be given by whatever you put on the pose. So the pose will transform this, and then what you put on the points. So if then you put a point with an x equals 1, it is going to be on this x. So this is, so the points, it's like frame ID, then pose, then the point coordinates. It's like a concatenation of transformations.
But if we make the pose dynamic, it works the same way.
If we make the pose dynamic, you are going to change the points dynamically.
Same way.
Yes, like when we changed the pose in your case, and you saw the cubes moving, but it was only a cube. If it was 100 cubes, the 100 cubes would move around. Okay? Of all the objects. If you have one, it's of one. If you have many, it's of many. Okay? That's it. From home, anyone needs help? Okay, see you next week.